Last time, we talked about the method to find out the inverse of a function. This time, we're going to follow the same standard method to find out the inverse of a function which has multiple pairs. This is often called multi-paired function or piecewise function. We don't really have to know much about piecewise function. We can apply the same principle, treating them separately. So first, we're going to have to make sure whether the function is one-to-one. That's the first point. We're going to have to make sure that. And to do that, we are already given that the function we have is already one-to-one, so we don't have to worry about it. An easy way to check whether a function is one-to-one, you can just draw the graph of this function and do the horizontal line test. If the horizontal line touches the graph only once, and if it continues to do so everywhere you draw the horizontal line on that graph, then it is one-to-one. Now we're gonna, alright, so this function is already one-to-one, so we're gonna write this part. So let's work on the first part. So let's work on this part, minus x plus 1. So we're gonna work on this part first. Check if it is one-to-one. Yes, it is. So we're going to write f of x is equal to minus x plus 1. Great. Now we're going to swap f of x for y. So to swap f of x for y, we're going to just write y in place of f of x, and everything remains the same. Now we have to interchange x and y. So we're going to switch our variables. We're going to switch x to y and y to x. It's more like going into the inverse world, right? So we're gonna write x in place of y, and over here in place of x we're gonna write y plus 1. So we interchanged x and y. Now we're gonna have to solve for y. So we solve this equation for y. And if we do that, we're going to get y is equal to minus x plus 1. And then eventually, we can replace y with f inverse. So we're just going to write f inverse of x in place of y. So we can do that. F inverse of x in place of y. And this is going to give me minus x plus 1. So that's for the first part. We're going to work on the other part of the function. So let's work it out. So the other part is for negative square root of x. So this is the part we're going to work on now. We're going to follow the same method, standard method of finding the inverse of this function. We're going to check if it is one-to-one. So is this function minus square root of x, is it one-to-one? It's already given the whole function is one-to-one, so the part of this function is also one-to-one. So we're going to write f of x is equal to minus square root of x. Now we're going to swap f of x for y. What that means, we're going to just write y in place of f of x, and everything remains the same. Now we want to interchange the variable. We want to get into the inverse world. So we interchange the variable, meaning in place of y, I'm going to write x, and in place of x, I'm going to write y. Now we will solve for y. So we will solve this for y. And to solve this for y, we can bring this negative sign over here. We can multiply it through with a negative, and we're going to get square root of y. And then we can actually square on both sides. So if we square on both sides, what we're going to get is this. We're going to get x squared is going to be positive now. X squared is equal to y. Or you can also write it as y is equal to x squared. It's all the same. Now replace y with f inverse of x. So in place of y, we're going to write f inverse of x. So we are writing f inverse of x, and this is for the other part. We have done this other part. So this is going to be x squared. So f inverse of x is equal to x squared. All right. So great. So, but we don't know what these categories are, right? So over here, the domain was specified for this function. Every time you define a function, you have to define the domain. But in this case, this category or domains are not specified already. We just constructed the function, but we haven't specified the domain. We have to be able to find out the domain. But how would you find out the domain of an inverse function? Because you know that after finding the inverse, the domain has already changed. And we have to be able to see how to find that. So let's erase some part of it to create some space. So I'm going to erase this part. I'm going to erase this part and work on finding out the domain. But to find out the domain, domain of this inverse function, we have to see an important relation that we studied in the theoretical description of inverse function. So see that the f for the function f, we can go from domain to its range. That's for f. Let's call it a goes to b. But that's for f. But when you're finding f inverse, then we do the opposite. So we go from b to a. So we're just doing the opposite. Now you see the important relation that you can see looking at this diagram is that the domain of f becomes the range of f inverse. Think about it column wise. This is the domain column and this is the range column, right? Now the domain of f becomes the range of f inverse. So we can see this connection, and then the range of f becomes the domain of f inverse. So you can see another connection. So they swap between each other. So what this important relationship tells us is that if we can find, alright, so what we really want to find out is the domain for f inverse, right? So this is what we want to find out, the domain for f inverse. To find out the domain for f inverse, it has a relationship with the range of f. So if we find the range of f, then we can use that as a domain of f inverse, and that solves our problem, right? So our target now is to find out the range of f. So we already know the domain of f, so we have to be able to find out the range of f to find out the domain of f inverse. I hope that makes sense. So let's try to find out the range of f. So I'm gonna create some space in here. So look at the first function. We're gonna work on f now. We're gonna work on this, and we want to find the range of f. So the range, let's look at the first one now. It's minus x plus 1, and we have this category x less than 0. Okay, so if we plug in any value smaller than 0, it's going to be negative. So any negative value, and we already have a negative in front of it. So negative, let's say negative 10. We're going to input negative 10 here, but we already have a negative, so that makes it positive 10 plus 1, so it's going to be 11. So what that means is the more negative value we plug in, the larger the range of f becomes. All right, on the other hand, if we plug in really small value, let's say not 0, but smaller than 0, let's say 0.00001, and then we get a really small fraction, right? So negative some fraction, and this negative makes it positive, added to 1, that makes it 1 point some fraction, 1 point something. But we're never really going to reach 1. So the range for this one is going to be, we're never really going to reach 1, and we can make a bigger number. We can also get a bigger number plug in really large negative value. So this is going to be the range for this one. So we are never going to get 1, so we excluded 1, and then we can go all the way up to positive infinity. That's for the first part. The second part of this function, let's work on this to find out the range. So let's find out the range for this function. What is the range of it? So let's write the function first, negative square root of x, and its domain is x greater than 0. This is the category we have. Now, what that means is we can plug in 0. So if we plug in 0 in it, square root of 0 is 0, negative doesn't matter then, so the biggest number that we can get out of this is 0. What's the smallest that we can get out of it? So if we plug in any number much greater than 0, let's say, I don't know, 100. So if I plug in square root of 100, it's going to give me 10. So we have negative 10. What that means is the larger the number we plug in this, we're going to get, smaller values like negative some big number. So we're going to get the smaller, more negative number we get, right? So which means we can, this way we can go all the way up to negative infinity. And the biggest number that we can get out of it is 0. And can we achieve 0? Yes. So we will indicate that by this. So we can go all the way up to 0. We can include 0. And on the other end of the spectrum, we can get all the way to negative infinity. Now, this is the range of this function. And we said that the range of f in f, will be the domain of f inverse. Now that we know the range of f, we can easily write the domain of f inverse. So from here, we can get any number bigger than 1 all the way up to positive infinity. So in this case, we're going to get x greater than 1. This is what we're going to get from here. So we can include any number greater than 1. That would be the range of f, and now according to this diagram, this range will be the domain of f inverse. So this range of f is going to be the domain of my f inverse. And on the other end of the spectrum, the other part of the function that we have, for this one, we're going to get x less than or equal to 0, right? See, we have this range, so we're going to include 0 in any number smaller than 0 all the way up to negative infinity. So this is coming from here, right? So finally, we can see we have found out the inverse of this function, and we have specified the domain of this inverse function. And what this x doesn't really mean this x. This is just a placeholder now. So we have found out the inverse function of this function, including these categories or domains specified. So this is the result we have found. And this is what we are asked to find out. What is f inverse? And this is f inverse.